Let's spend a few minutes practicing and illustrating some of the possibilities when we use the data transformation functions. I'm going to continue using our flights data. I'm interested in knowing if arrival delays are related to the distance of travel. So let's see what we've done. We've taken flights, we've piped it to group by destination, we've summarized using a count function that is n, a mean function for distance, a mean function for arrival delay. So we're going to get the count, that is the count by destination. We're going to get the mean. We're going to get the arrival delay. Then we're going to filter and only look at those that have more than 20 flights that year. So I'm basically filtering out all of the destinations that are rarely gone to. And then we're going to plot this using distance as the horizontal axis and the delay as the vertical. We're going to use a geom point, and we're going to use the count that we got up here. Okay, here where we set count equal to the number, that's the n function. We're going to use the count from up there and make the size of the point based on the count. And then we're going to put in a smoothing function where we're not going to have the standard error. So that is, I'm not going to have a confidence interval around it. And notice all of this is done in one fell swoop. All right, so let's open up this window a little bit for our plot. Let's hold our breath and see what we get. How's that for cool? So here we're looking at the distance, but we're also looking at how many flights go to that particular destination. And those are shown by the size of these points. And we're also putting in a little smoothing line to see if we can detect a trend. Notice that once we get here to around 500 miles, just over 500 miles, that it starts coming down, that the delay is less and less as the distance increases. But for the first little bit in here, we have a lot of our highest delays. What did we use? We took the mean of the delay, again, by destination, okay? We also noticed that our most frequent destinations, these big points here, where we have over 16,000 flights in the year that go to these points, they tend to not have quite as many delays down here as some of the other groupings, such as 4,000 or less. Notice that the smaller points are for less. Remember, though, that we didn't include anything with 20 or fewer flights in this data set. So all that stuff we accomplished with this one set of commands with our pipes. I'm hoping by now you're saying to yourself almost out loud, that's really cool. If not, please say it now with me. That's really cool. All right, let's try another one. There's one distance outlier that's heavily influencing the results. Let's see what that destination is so that we can eliminate it. Notice this? This one outlier here, it's kind of pulling everything out that direction, and it's all by itself. So let's find out what that one is at that big distance. It's the only destination over 4,000 miles. And so we're going to look at this. This data set, by the way, I should have told you this before, is only for domestic flights. So I bet you can guess what this one is now here over 4,000 miles. But let's take flights, group by destination, filter the distance to be greater than 4,000 miles, and select the destination. That should narrow it down for us. Let's try it. It's Honolulu. So that is what is heavily influencing this chart. So let's do it again, but let's go ahead and remove Honolulu. So look at what we've got here. Flights, everything the same up until this point. I'm filtering now on two things. Count has to be greater than 20 and the destination not equal to Honolulu. Remember, of course, the exclamation equal means not equal to. So now let's see what the plot would look like if we removed that one outlier. That's actually probably a better picture for us. Honolulu is way far away compared to the others. So this gives us a better indication of what we've got here. Oh, and here I say, this data set must be only domestic flights. Some of the destination counts amaze me. I want to create a data set that includes flights to the most popular destinations from New York City. I mean, look at this, 16,000 flights in a year to some of these destinations. So let's do this. Let's look at popular destinations. We're going to make a new data set we're going to call popular destinations. And we're going to take flights, group by destination, summarize the count, and filter so that it's over 10,000. So let's see what destinations have over 10,000. And I've stored that now in popular destinations. So if I want, I can look at popular destinations. Here are some of them: Atlanta, Boston, Charlotte. What is FLL? Fort Lauderdale? I don't know what FLL is. LAX is LA. Not sure MCO. Miami, O'Hare, San Francisco. And notice that's it. Those are the only ones. This is a 9x2 tibble. We're seeing the entire set of popular destinations. If I want to capture all the flight information for these popular destinations, now that I've created PopDest, look what I can do. I'm going to now take PopDest flights. It's going to be flights, pipe to filter on destinations that are in PopDest. So here I'm taking the PopDest data set or tibble, and I'm referring only to the variable des, so it doesn't put count in there, and that will give me the popular destinations for all those flights. Yeah, well, actually all the flight information for those 9 popular destinations. That's what we get in that. So if I were to look at pop.dest.flights, I'm just curious to see how big this data set is. 131,440 flights out of New York City are only to those 9 popular destinations in the year 2013 where this data set came from. Now, when we did summarizing up here, you saw me start to use some different things. I used N for the count. I used mean, which we're familiar with that. Here I used mean a couple times. What else can we use in the summary function? So let me show you a few of the summary functions that we can use. If we're looking at the center of the distribution, we can use mean or median. If we're looking at the variation, we can use standard deviation. We can use interquartile range or median absolute deviation. For rank, we can use minimum or a quantile, and you can use any quantile you want, or maximum. For position, we can ask for the first, the last, or we can even ask what's the nth position. We can use counts for n or count x, or we can use n distinct, which would only count the number of distinct values that we have.